Good morning. My name is Victoria Sampson. I'm with the Secure World Foundation, and I've been asked to welcome you to the second day of the 16th Advanced Maui Optical and Surveillance Technologies Conference. Thank you all for sticking around and for getting up early for the session. I think it should be really interesting. We'll be starting off with our keynote speaker, who is John Hill. He is the Principal Director for Space Policy, Office of the Undersecretary of Defense for Policy, and his office is responsible for formulating and carrying out space-related national security and defense policy, including the conduct of international space cooperation. John.
Good morning. I'm glad to see you made it in at least half sober. Well, first, it's great to be back in Maui. I think this is my third time here. First time at this conference, but it's great to be here in Maui again. Let me begin by thanking Jeannie Skog and Sandy Ryan and all the members of the Maui Economic Development Board for producing this great 16th annual AMOS conference. This is a tremendous event for the space community and the space situational awareness community in particular, and I'm honored to have the opportunity to speak here today. Let me also thank every one of you, not just because you're coming here to hear me talk in the morning, but to thank every one of you who is here this morning and commend you on your dedication to the benefit of the world and the betterment of humankind. I mean, just think about it for a second. Space situational awareness is fundamental to everything we do in space and to all the benefits that humanity derives from space. And here you are in Maui. The sun is warm, the breeze is gentle, the sand is soft, but instead of succumbing to the siren sounds of the surf, you, the dedicated attendees of this conference, have chosen to sit in a windowless ballroom that has too much air conditioning and listen to a Washington bureaucrat hold forth, hoping that he will have something useful to say on this morning's topic of space situational awareness for enhancing norms of behavior and resilience. I know if I were in your place, I would be headed to the beach so fast that neither the J-Spock nor the ComSpock could track my orbit or calculate my ephemeris. Now, as I said, this morning's session, I've been asked to get things started by talking about space situational awareness for enhancing norms of behavior and resilience. But in all seriousness, that topic sounded to me like just about the worst combination of policy wonk and space geek you could possibly imagine. So naturally, I decided to talk about something else. And specifically, what I want to talk about this morning is space mission assurance. And that is not because SSA norms and resilience are not important. To the contrary, they are vitally important, and they are directly related to mission assurance. And I will talk about each of them in due course. But SSA norms and resilience are not the ends that we seek. Rather, from a strategic perspective of ends, ways, and means, all three of those are simply ways. And I suppose at this point, it's a good point to remind all of you that my background is in political science and national security studies. So I apologize in advance if I don't have enough equations for you in my talk, and if I use too many references to obscure military strategists. But at any rate, as I was saying, from a strategic perspective of ends, ways, and means, SSA, norms, and resilience are merely ways of pursuing the end of mission assurance. SSA concerns everything we encounter in the space domain. Space is the way we understand the environment in which our spacecraft operates. And without that understanding, the success of our day-to-day operations becomes something of a crapshoot. Norms refer to human behavior. Norms are an essential tool for sustaining safety, stability, and security in space. Whether they are formalized in treaties or simply are a consensus-based set of well-understood and observed best practices, norms are the ways we regulate human activity in the space domain to increase predictability of operations, improve safety of flight, limit debris, and sustain the space environment for the benefit of all over the long term. Resilience concerns the space systems themselves, including their ground segments and links. It is a function of the various means by which we improve the inherent ability of our space systems to withstand the various hazards, both natural and man-made, that they encounter in the harsh environment of space, as well as on Earth. But none of these three, SSA, norms, and resilience, are the reasons why we put spacecraft in orbit in the first place. We launch spacecraft to perform specific missions, such as communications, Earth observation, scientific research, missile launch detection, positioning, navigation, and timing, and any number of other missions. And we want to carry out these missions with high confidence of success. And that is where mission assurance comes into the picture. Now, when we hear the term mission assurance, we often think about systems engineering and program management. In fact, on the aerospace website, and by the way, I want you to know that even though my background is political science, I do consider aerospace to be even more authoritative than Wikipedia. On the aerospace website, we find that, quote, mission assurance is the disciplined application of proven scientific engineering, quality, and program management principles toward the goal of achieving mission success. It follows a general systems engineering framework and uses risk management and independent assessment as cornerstones throughout the program life cycle. I actually have no idea what that definition means, but I'm sure that in its context, that definition is absolutely correct. And in fact, that understanding of mission assurance is vital in the precise and delicate business of designing, manufacturing, launching, and operating spacecraft. But what I'm talking about is somewhat different. As a well-known Department of Defense official and longtime space guy who also happens to be my boss testified last March before the House Armed Services Committee, space mission assurance is the means of securing space-based services so that our forces can count on those services being available to them whenever and wherever they are required, end quote. I would add here today that the concept Doug Lavero was describing in that testimony is not just limited to the world of national security space. Whether you are a civil, commercial, or national security operator, space mission assurance means knowing that you will successfully provide specified space-based services when and where they are needed and expected, at the designed rates, volumes, and levels of fidelity, and notwithstanding whatever hazards may come your way. Historically, those hazards have come mainly from nature and, of course, from the launch vehicle that's supposed to put the satellite on orbit in the first place. But as space becomes more congested and contested, increasingly those hazards come from human activity. The vast majority of that activity, both intentional and unintentional, is entirely unassociated with malign intentions. But such activity can nevertheless still pose hazards with which all space operators must contend. And to the extent that we face an increasingly contested environment and may also have to contend with hostile activity, we must take all steps necessary to assure our national security space operations against those hostile activities and thereby sustain the role of space forces in underwriting deterrence. So in this framing of the problem, mission assurance is the end that we seek, while SSA, norms, and resilience are three very important and interconnected ways in which we go about accomplishing that end. And it is in that context that I want to say a little bit each about SSA and norms, and then focus most of the remainder of my comments on their intertwined role, along with resilience, in achieving mission assurance. Turning first to SSA, I think it was the great Russian astronautics engineer and novelist Leo Tolstoy who described the importance of space situational awareness best when he wrote, "All nominal space operations are alike. Each anomalous space operation is anomalous in its own way." For those of you physicists and engineers who didn't take Russian literature as your breadth elective, that comes from the steampunk edition of Anna Karenina. But I adapt that line from Tolstoy because it underscores why SSA is so important. When things are nominal, they are going according to plan, and they do so every day. But when something about our space mission is not nominal, there could be any number of explanations. It might be something in the design and manufacture of the system, which is what that aerospace definition of mission assurance gets at. But the cause of the anomaly could very well be external to the system. And the better our SSA, the better we will be able to identify and isolate the root causes of anomalies from sources external to our satellite. And even better is the situation when our SSA is so good that we can anticipate those root causes before they affect our systems, and thereby avoid the whole problem in the first place. So whether the concern is radiation or magnetic disturbances or RF interference or debris or a deliberate attempt to degrade or destroy our satellite, the better our SSA, the better the likelihood we will be able to diagnose problems and threats and identify indicators of those problems and threats before they arise and take timely evasive actions. And that improves mission assurance for our customers. And whether our customers are military forces in harm's way or football fans wanting to see if the New England Patriots are deflating the footballs again, or 35 million frozen Canadians wanting to watch curling with the stars, that's even more popular than hockey night in Canada, isn't that true, John? They count on our services to be there when they need them, with the promised rates, volumes, and levels of fidelity. And it is because of this critical importance of mission-to-mission assurance that the Department of Defense concluded in our recent strategic portfolio review of space that we must increase emphasis on SSA in our annual budgets and in the way we operate. Turning next to norms of behavior. Norms help us reduce the hazards that we might otherwise create for each other as a result of our operations. Norms are especially important to preserving and sustaining the global good that is space, and ensuring space will continue to benefit the global world, global economic growth, and be an enabler for services that lead to better lives around the world. To the extent we are able to establish norms, SSA is fundamental to the ability of space operators to comport themselves in accordance with those norms. And it is also fundamental to the essential task of verifying compliance. In the national security field, norms also can help us reduce the risks of misunderstandings and miscalculations that can lead to conflict. This is just as true in space as it has been for a century in airspace and for even longer at sea and on the ground. Of course, in space, we really don't have all that many hard and fast rules for how we operate, other than the prohibitions under the 1967 Outer Space Treaty on placing nuclear weapons in space or on the moon or other celestial bodies. And I know I'm willing to trust that none of you have violated that prohibition about placing nuclear weapons. But there's a lot of other norms that require more than trust. They require verification, and it becomes very difficult. There are also treaty-based norms about registering spacecraft and liability. There are debris mitigation guidelines established by the UN Committee on Peaceful Uses of Outer Space. There is also the consensus-based system of norms established through the International Telecommunications Union for allocating slots in geostationary orbit. But basically, operators in space are pretty much free to do their own thing. And similarly, in the United States, there are also license requirements for launching space systems, guidelines for mitigating debris, license requirements for communications systems, and license requirements for imaging systems. But once operators have spacecraft on orbit, they, again, are mostly free to operate as they choose. Of course, compared with operating in space, developing norms for operating in space is not easy. I mean, space operations is merely physics. Establishing and negotiating norms is metaphysics. It's not easy in the domestic context of a single government, and it can be downright near impossible in multilateral contexts. If you think about it, in government bureaucracies and in multilateral bodies, there are basically two forms of motion. Government motion is either inertial or it's Brownian. By the way, for the physicists in the room, those again are political science terms. Unfortunately, it often takes a crisis before we can generate the consensus necessary to focus on developing satisfactory, sustainable solutions and generate deliberate, purposeful motion in government or multilateral bodies toward productive ends. This afternoon and in Friday's session, there will be discussions about space traffic management. Space traffic management may be ripening as an area for development of norms that can stimulate economic opportunity by strengthening space sustainability in an era of rapid growth of space traffic, especially the traffic made possible by the revolution in small satellites and development of increasingly responsive launch services. And that takes me to resilience, which, as I said previously, concerns the space systems we deploy and operate. Resilience is a primary way of achieving mission assurance, and resilience benefits from both good SSA and good norms that are reinforced by good SSA. I would like to spend a few minutes putting resilience into its context with the help of one slide. So at this point, this being a DoD presentation, I really felt that I had to have a slide. I apologize that there's so many words on there for you to read. But this slide depicts what we in DoD refer to as our space mission assurance taxonomy. It's something that was developed in the course of the strategic portfolio review. In fact, it took us 18 months to come up with that. But we still haven't quite reached agreement. There are a number of ways to improve mission assurance. As you can see at the top, some of those ways may involve providing the same services from other domains or across multiple domains. And typically, those solutions from other domains or cross domains do not fully replace the capabilities provided from space, particularly for supporting forces that are operating globally. But for forces operating regionally, cross-domain and non-space domain solutions can be part of the answer. Coming down the chart a bit, in the center column, within the space domain, there are basically three approaches to increasing mission assurance. First, we can defend our assets. We do that on land, sea, air. Why not do that in space? That is, we can protect them with defensive counter-space systems that may be able to defeat a threat. These could be on board or off board the satellite that we want to protect. That's probably of more interest to the military than the commercial operators, but I'm giving you this from the military perspective, and I think some things here do translate to the civil and the commercial context. The second approach is reconstitution. And that is simply the ability to rapidly restore a capability if it is lost. Here, I think there is a lot of unexplored potential in the areas of small satellites and responsive launch. We really have only just begun to investigate the art of the possible in these fields. And moreover, in both of these areas, as is increasingly the case in space, the greatest innovation is not coming from government, but from the private sector. And government needs to ensure that it remains open to such innovations and willing to accept some of the risks that may come with their adoption. We're very comfortable accepting the same risks that we take every day, but that has a lot of risk. Sometimes we need to take a different risk. We're more uncomfortable with it, but sometimes it's the better risk to take. The third approach to space domain mission assurance is the one I want to focus on today, and that is resilience. Stated simply, resilience refers to the inherent characteristics of a satellite that make it able to withstand the hazards, both human and natural, and the threats that can disrupt, degrade, or destroy the satellite. Over the past 2 years, we in DoD have largely organized our thinking about resilience into 6 areas. The first means of achieving resilience is through deception. As those of you who are fans of Sun Tzu, and I know there's a lot of you out there, as you will know, deception is at least as old as the art of war. So I don't think I need to say too much about it here, except that, like defense, it's probably of more relevance to the military than to civil and commercial operators. The second means is one that has received a lot of discussion, but that is also somewhat misunderstood, and that is disaggregation. And let me begin by emphasizing that not all disaggregation necessarily contributes to resilience. There may be many reasons other than resilience to disaggregate systems and capabilities, but in some cases, disaggregation can be particularly important for resilience, especially when it comes to disaggregating certain nuclear and conventional missions. That is, when our space system is used exclusively in connection with nuclear-related missions, such as nuclear command and control or strategic missile warning, and that fact is communicated clearly and credibly, then the system is more likely to benefit from extension of the nuclear deterrence paradigm that applies to the nuclear triad and other related systems. On the other hand, when I start commingling nuclear and conventional missions onto the same system, and the conventional missions become increasingly important to the way I operate in conventional conflicts or on a day-to-day basis, and an adversary may conclude in a conventional conflict that there is little choice but to take away that capability. That situation can reduce the mission assurance of my systems that support our nuclear capabilities and the President's decisions about those issues. And that can create greater uncertainty regarding the adversary's intentions with respect to nuclear escalation. And those factors complicate my own decisions. They complicate my own decision-making, and they can detract significantly from nuclear deterrence. And none of that is a good thing for anybody, and anybody includes me and my adversary. So in DoD, we are looking very carefully at this question of disaggregation, particularly from the perspective of how we group particular missions on particular systems, and how that relates to deterrence, and in turn, how that relates to the resilience and mission assurance of our systems. Now, the final four means of achieving resilience relate more directly to system architectures. First is distribution of a mission across multiple nodes of the architecture, and I think the classic example of this is the global positioning system. To provide complete coverage, I require 24 nodes. I have more on orbit, but I require 24. But a user on the ground only needs to access 24 of these nodes. So an adversary may take away one or more nodes, but I can still deliver capability to my forces, albeit potentially degraded in some areas. Next is diversification of the ways in which I accomplish a mission. A simple example here is using my organic military satellite communications as well as commercial satellite communications and the SATCOM systems of my allies. If I have a diversity of sources for the services I require, it becomes much more difficult for an adversary to deny me those services. I think you will see a lot more diversification in the future. The fifth means of increasing resilience is proliferation of a system. In MIL-SATCOM, the wideband global SATCOM system with 6 and eventually 10 satellites on orbit provides resiliency through proliferation. In the commercial arena, Iridium's architecture of 66 satellites and 6 orbital planes is another example. And most recently, we are seeing highly proliferated commercial remote sensing architectures, some of which have dozens, even hundreds of satellites on orbit. The final means of achieving resilience is protection. This could include anti-jamming systems, radiation hardening, maneuverability, onboard countermeasures that a satellite can use to defeat particular threats. Obviously, these means are not mutually exclusive. For example, we can use a proliferated MIL-SATCOM system, combine that with diversification through use of commercial SATCOM, and then develop protected tactical waveforms that work on both systems. So when you think about it, everything I just described is something the military does as a matter of course in each of the air, land, and sea domains. We are used to thinking about land, sea, and air as being contested. But in space, this is a new challenge. The United States is determined to rise to that challenge because we absolutely must assure the space operations that are integral to how our forces fight. This is critical both to sustaining and strengthening deterrence and, if deterrence should fail, to prevailing in conflict. So to summarize, improved SSA is vital to efforts to establish, implement, and enforce norms, and it is vital to resilience of systems. Norms, to the extent we can establish them, can also contribute to resilience. And SSA, norms, and resilience are independent and intertwined ways of contributing to our ultimate objective of space mission assurance. All three of these ways require continued effort, not just for the benefit of national security space, but for the benefit of all space operators. Because whether we are securing the nation or conducting any of the myriad civil and commercial space missions that advance science, generate economic growth, or improve the quality of life on Earth, mission assurance of our space operations is indispensable to mission success. Thank you for your time and attention, and I look forward to questions.
Again, my name is Victoria Sampson. I'm the Washington Office Director of the Secure World Foundation. We're a private operating foundation that focuses on the sustainable use of outer space. I'm here to moderate this panel on SSA, norms, and resiliency. We've got some fantastic speakers, one of whom you just heard. We'll be starting first with Andrew Duva, the President of Providence Access, a government affairs, technology, and satellite consultancy. He has supported international commercial satellite and telecommunications business on the regulatory, policy, legal, and operational fronts for 2 decades. And he was involved in the original strategy, legal framework of the Space Data Association, we'll be hearing more about later. And we'll go with Andrew. Thank you.
Thanks, Victoria, and good morning, everybody. Congratulations on surviving the tsunami. There's always something interesting in coming to Hawaii. It's wonderful to be back here, and I want to thank, in particular, Jeannie and Sandy from MEDB for the invitation and the conference committee for allowing me to be here again. John is a tough speaker to follow, but I think he's laid out some very, very important points about, in a surprising way, I was surprised to hear about mission assurance. One of the areas in SSA where I was privileged to participate in some years ago was working in a cross-industry team as part of President Obama's National Security Telecommunications Advisory Committee, where I was the principal editor for, again, an industry consensus view on satellite mission assurance. We identified 3 areas that were particularly troubling from a mission assurance perspective. One of those was radio frequency interference. One of those was cyber-related. And the third, relevant for here, was the growing problem of space debris and the lack of collaboration and cooperation among various space operators. That report, many of the recommendations in that report ended up being reflected in the 2010 National Space Policy, which encouraged data sharing, which encouraged collaboration, which again tried to extend the U.S. leadership in this area through operations to establish norms. What we found, and where I sit, is typically on the commercial side. What we found is that, as John pointed out very eloquently, that there are not many rules, let alone norms, of operational behavior in space. And so several operators decided that, at least among themselves, it might make sense to build a common operating picture of what they were doing and some of the known hazards in space and try to operationalize that. And that was the foundation for the Space Data Association, which is a voluntary organization made up of commercial, civil, and military satellite communication systems. Not all in the world, unfortunately not yet, in different orbital regimes, both GEO, MEO, and LEO. And the basis for SDA was one of enlightened self-interest. The idea behind it is that satellite operators, through various technical means that you're all well aware of, probably have the best information on where they are. That's a arguable point, but that was the belief, that the operators, through cooperative tracking, knew where they were, and of course only those operators knew when they intended to make a change in their operations or a maneuver. So we, working with AGI, who's many of whom are here, we built an information system where those operators could combine those ephemeris, the ephemerides and the advanced maneuver plans, combined with information that was made available by the US government through spacetrack.org, and now through a SSA data sharing program, more high fidelity information. SDA sought to provide collision warnings and also take into account the advanced maneuvers. So if you're doing a maneuver and you know that in advance, is that going to create a problem with one of your neighbors or with a known piece of, a known RSO? It's been very successful, but it's not nearly enough. But the interesting point from a norms perspective is that the operators involved, who in the commercial case are strong competitors, have decided to find a way to share information that they would normally consider proprietary or sensitive for their own enlightened self-interest. And another norm that emerged was that operators who had, from a legal perspective and from an international norms perspective, been free to do essentially what they wanted in space, agreed as a private law matter to notify into an information system maneuvers before execution and check that against possible harm. And so we see in the private sector the emergence of this signal before turning, if you will, norm. And that's one concrete thing that I think we can point to that is the very, very basis for space traffic management. There's a lot, as John said, we'll talk a little bit about space traffic management this afternoon. I think we're at the very, very early stages of that, because in order to manage something, one needs to understand it. One needs to understand the environment and have some certainty of the truth. And one of the things as a non-technical person I learned coming into this field some years ago was that we don't know where everything is. And there are limits to our precision and limits to our accuracy that we can do. This is not well known. To all of you in this room who are subject matter experts, it is entirely well understood. But I urge you, in working with particularly the emerging space actors, to share your experience with them and let them know that despite all the many tens or hundreds of millions of dollars of investment in sensors, processing systems, capabilities, that the truth is still, it's not deterministic, it's probabilistic maybe at best. And that means that our norms and our way of operating require us to work together. In the military context, that's not always the case. Just as on the sea there are submarines that operate with their own set of norms and keep out of the way of civilian traffic, but conduct their missions. In space, there are submarines that operate in their own ways and keep out of the way of other satellites, one hopes. But for the vast bulk of systems, we have transparency that's emerging. And I think that's a very, very important thing to recognize, that the limitations of our ability to sense and react mean that space traffic management, at least for a while, is really going to be about finding rules of the road that are in one's self-interest, like notify before maneuvering, like sharing your information about where you are, like understanding the different coordinate systems and references, and so that data are normalized. That's one thing we found within SDA, is that everybody thought they knew where they were, and they did, but they didn't know correctly where they were in relation to anyone else because the systems they were using weren't actually in the same frame. This all became painfully obvious to us, and again, may be well known to you, but I can, from a commercial and civil perspective, I can tell you there's a lot of learning that still needs to go on. So with that, I think our work is cut out for us. The answer does not lie entirely in systems and in science and in the technical aspects of the work that we do, although it's critically important. I think the real answer lies in collaboration and sharing. So it's very good to see, I believe this is my sixth or seventh, I think this is my sixth AMOS conference. And I've watched the dialogue, particularly from the US government, where they've been postured, go from one of we wanting to understand and control the environment in a sense of control the knowledge and information and centralize it and keep it safe, to one of a posture of engagement, data sharing, and a collaborative, virtuous circle, if you will, of engaging with space actors to improve knowledge, to share best practices that have been worked out painfully over many decades in a bipolar world of the US and the Soviet Union, and share those out so that we, mostly as commercial industry or civil industry, as new actors, don't have to suffer those same challenges. And it's a really, really encouraging thing, but our work isn't done. So thank you very much. I'd be happy to take questions later as part of the panel.
Thank you, Andrew. Next, we have Eric Desautels of the U.S. State Department. He heads the Office of Emerging Security Challenges in the Bureau of Arms Control, Verification, and Compliance of the State Department, as I said. His office leads the Office of the Department of State to implement security aspects of the President's national security policy by promoting outer space cooperation and engagement. And they work on transparency and confidence-building measures, particularly looking at the formulation and implementation of national security, international relations, space policy, including space situational awareness, information sharing. Eric?
Thank you, Victoria. Thank you for that introduction. You've already heard quite a bit about what I was going to say, but I think I'll press ahead here and try to give you a slightly different perspective than the commercial perspective and the perspective that John was bringing on how the State Department looks at space situational awareness and how we would use the data that is provided to us. You know, unfortunately for us, with our very meager budget, we do not own or operate any satellites or any space situational awareness systems. So we seek to take the information that is available and use it to achieve our goals of attributing events in outer space and then holding countries or groups accountable for their activities in outer space. As we've seen in both the cyberspace domain and in outer space, it is particularly difficult to attribute these events. And then even if you have an opportunity to figure out what the event was and who conducted that event, the question then becomes, how do you hold that government accountable if there are no rules of the road? And so the attribution part that space situational awareness helps us with, as you all know, is far more difficult in the outer space environment than what occurs on the Earth. You know, it is nearly impossible to conduct a similar type of fact-finding mission that we can do here on the Earth. Now, that's not to say it's not a challenge sending a team into Syria to conduct an inspection of whether chemical weapons were used, but it is still a much easier challenge than it is to try to send somebody into outer space to figure out what happened to your satellite. And then second, on Earth, if there is evidence that a weapon was used, it's going to most likely be a man-made event. In outer space, you have the challenge of natural events, space debris, or even hostile activities that could explain why your satellite suddenly stopped working. And that is why we need the space situational capability to understand what is going on in outer space and attribute any unusual events, as John described in his Anna Karenina steampunk analysis. And just as we need an international coalition on Earth, the international cooperation on space situational awareness is equally essential, and it is a key role of the State Department to promote that cooperation. I had the opportunity to head down to Exmouth, Australia just last week to see the new site of the C-band radar and get a great feel and appreciation for how our allies and partners around the world can help us expand our ability to do space situational awareness, both by bringing additional resources, geography, and capabilities that enhance our capability to warn and attribute of attacks. And even with this amount of space situational awareness, the next challenge becomes, how do you hold a country accountable for their activities? I think John mentioned, the physics of all of this, the technical challenges are significant enough, but then when you try to layer in multilateral diplomacy, where not every country in the world agrees with what you're doing or may have a different opinion of what you're doing, it can make it a significant challenge in creating those norms that you need to hold countries accountable. And as John mentioned, there are very few rules of the road right now. You have the Outer Space Treaty, the ITU, and others. There's the Limited Test Ban Treaty that says don't test your nukes in orbit as well. There's the Law of Armed Conflict, which the United States strongly believes applies to outer space, just as it does on land, at sea, in the air, and in cyberspace. But just as we have done in those domains where we have hundreds of years of practice on the land or at sea, we need to develop these responsible rules of behavior for the outer space domain. But the question is, what approach should we take? Some are pressing for a treaty on these issues, but given the exponential growth in technology and our inability to really define what malevolent technology in space even looks like, or how we could even verify that a system was designed to do what it says it is, we may not want to go down the road of a treaty or a legally binding agreement at this point in time. And that is why the State Department, working in concert with our interagency colleagues, such as John's office, and our allies and partners around the world, is working to develop those non-legally binding norms that may one day become legally binding, but we need to have the experience and set the foundation now in a more non-legally binding manner. And so, for example, for the past decade, as John mentioned, we've been working with the UN Committee on Peaceful Uses of Outer Space, also known as COPUOS, to promote guidelines on space debris mitigation, including a guideline to avoid the intentional destruction of any on-orbit spacecraft that generates long-lived debris. The United States is also taking a leading role in efforts to develop guidelines for satellite collision avoidance and enhanced space flight safety. Then there's the European Union's International Code of Conduct for Outer Space Activities. This contains a very important norm in addition to all the transparency and confidence building measures in the agreement, where in paragraph 4.2, there's a provision that calls on states to refrain from any action which brings about directly or indirectly damage or destruction of space objects. The code also creates a consultation mechanism that allows for investigations regarding activities that are believed to be contrary to the code. So these and other norms are essential to our diplomatic efforts to enhance the safety and security of the outer space environment. And our ability to do that is underpinned by the strong space situational awareness capabilities that people in this audience are bringing to our government. Let me stop there and thank everybody for your hard work and impressive efforts here, and I look forward to answering any questions you may have.
Thank you. Well, moving on to the questions. You can text your questions to the number on the screen above. We've got a bunch in the queue, but could always use some more. There are a lot of questions that are on the same theme in terms of compliance of norms. There are concerns that perhaps they aren't useful because bad actors won't follow them. I was hoping the panel could talk a little bit about the U.S. thinking on that and how, when you're developing these norms or looking at norms, how do you account for that sort of situation?
So the bureau in the State Department that I come from is actually called the Bureau of Arms Control, Verification, and Compliance. And so the verification and compliance aspects of any agreements are at the forefront of our considerations as we create these new norms or agreements. Now, it is obviously a challenge. Verification in particular is a significant challenge. That's why we need to have these strong space situational awareness capabilities so that we can detect what happens and how that event occurred. And then at the same time, then you have the issue of how you make sure that in a non-legally binding context, you can bring a country into compliance. Some of the ways, we see sanctions are one of the ways we often use to bring countries into compliance. We actually have a report that we put out annually that lists all of countries' compliance with their international agreements and commitments. And so, while it may seem like another type of report, it does get a lot of attention. It does get the country's attentions, and a lot of countries don't appreciate being on that list. We often get criticized, but if a country is not in compliance, we can send them a really, really angry letter that, hopefully will get them to take action. But there's oftentimes you can see where once a norm is created, you can create an international groundswell where a lot of countries can help you, and that's where having these allies and partners that are committed to these norms can help you press these other countries to stop doing the bad things that they're doing. I think there's plenty of interesting examples of this. I think the Chinese 2007 ASAT test, which then, we haven't seen a repeat of that since 2007. It may be a good example where pressure brought by the international community can change the way a country acts and behaves in this sphere.
I would just add, mostly from a commercial perspective, one of the ways that we encourage adherence to norms is by banding together and creating a sense of responsible actors and communities and places, whether that's through trade associations, through operational means like SDA and others. You create those forums where responsible actors participate, and that creates sort of a critical mass where the folks that don't participate in those forums become increasingly isolated. And so there's a bit of shaming, if you will, and there's also a bit of, well, this is, if I'm new, where should I go? What should I be doing? They look for those examples. So we try to encourage that. It's not, of course, never legally binding, but it's most space operators want to be seen as responsible, not out of any altruistic approach, but really just in an enlightened self-interest, in that if the environment they operate in becomes damaged or degraded, that interferes with their ability to carry out their mission. So we try to encourage that.
So, make sure I turn this thing on. So it was on. I think part of what you have to keep in mind with norms is you're dealing with companies in the private sector, but you're also, what we're really talking about here for the most part is nation states. Sometimes you have non-state actors in some areas, but let's limit it to nation states here for the most part. And one of the norms that we all live with and accept is that nation states do end up determining for themselves what are their inherent national interests and their inherent national defense, national security interests. They don't all agree with each other on those determinations, but at bottom line, nations determine those things for themselves. So that's one of your foundational aspects that you have to keep in mind when you're thinking about creating the norms. And when you're thinking about what is a realistic norm to create, what is the likely critical mass of nations seeing their national interest in alignment with whatever that norm is you're looking to create. Because while you can look at trying to enforce compliance, you fundamentally have to build the norm in a context where you're saying there is an inherent interest of a critical mass of nation states in self-enforcing that norm, and then deal with the outliers. Now, if it's in an area where the one outlier can be a huge risk and a huge threat to everyone, then that may be too hard to accomplish. So don't try for perfection. Don't try for your hardest things first. You're going to have to start small. I mean, the ITU is still not a treaty. The ITU started in 1865 dealing with telegraph communications, and it's evolved over time through the operators, much in the way I think Andrew was describing some of the more recent activities, commercial operators looking at some shared self-interests and coming up with ways of sharing information of how they're operating. That's how the ITU process has evolved in some of those same ways. So you do want to try and come up with something that can be verified. The ability to verify is very important to establishing norms, and the more risk that is involved with it, if you're dealing with nuclear weapons reductions, verification is really, really important. If you're dealing with jaywalking, it's not so important. And so you have to weigh the verification ability relative to the risk that's involved that you're dealing with the norm, relative to how the different nation states are going to see their inherent national interest in alignment with the particular norm.
For the panel, there's been a lot of discussion about responsible space behavior. I'm wondering if you could talk a little bit about how you view the distinction between irresponsible space behavior and hostile actions in orbit. Is that simply a matter of intent, or is there something else there?
How we view irresponsible space behavior, say that once again, please.
Irresponsible space behavior versus hosile actions. How do you define the difference between the two?
Yeah. And is hostility between nations irresponsible, whether it's on land, sea, air, or space? Well, first of all, I am glad to hear that we do know, for one fact we learned today is that the State Department is not engaging in irresponsible actions in space with any of their satellites. That's an important important takeaway. Did you want to respond, Eric?
I was just going to say that we practice what we preach. We are all for norms in outer space, and we are going to follow them all.
It is very, very hard, and it's probably easier if you look at it on Earth, and you see activity on the seas. And we've had a number of incidents over in the Western Pacific, U.S. naval vessels, Chinese fishing craft, and so forth. And in the sea, you actually have some written rules. You have the United States Convention on the Law of the Sea, which is very thorough in many aspects, and you also have agreements written between the United States and China have worked on, the United States and Russia have worked on agreements, and we have written down activities, what is expected to be responsible behavior and proper behavior on the sea. That doesn't mean, and so when you see something, you can say, that's irresponsible. What we're seeing this vessel do is irresponsible. It's not safe. It's mostly focused on safety of operations. And you can approach the counterpart nation and register your concerns and deal with it. But it is hard to disentangle whether that, the question that you asked of is that irresponsible behavior purely irresponsible, or is there something that is motivated from, I'll call it a hostile intent. It may be an intent to learn how somebody reacts to a situation. It may be an intent to gain information. It may be an intent to harass, or it could be purely just irresponsible operations at sea. So now take it into space. We're focused for the most part on the sustainability of space and ensuring that operators can have the confidence that the environment is not getting worse in space now and in the future. That's where most of the questions about what is responsible or irresponsible been. The issue of when somebody is doing something that is hostile or just irresponsible, I think that it's not as clear in terms of the established norms. It does become clear if they blow up your satellite that was probably hostile. But short of that, I think it's even harder to disentangle than it is on Earth, where you've actually established some of the norms, but still you're not always sure what the ultimate intention is behind the actions that you see.
I'd just say very quickly to pick up on what John said. I think irresponsibility implies that there is some norm or understanding of what is responsible. So is it irresponsible for a CubeSat proponent to launch satellites or cause the launch of satellites that cannot be maneuvered or whose position cannot be accurately and routinely determined? I don't know the answer, but I know that such satellites are actually just debris at one level, even if they're carrying out a useful mission. But we do not have a norm that states that all satellites launched into orbit need to be maneuverable, or their position needs to be determined and communicated to one or more centralized points. That norm may emerge. I don't know, is it irresponsible?
Just to add one thing, I think part of the challenge of answering this question is that this is all so new. We don't have a lot of experience with what is hostile behavior in outer space. We're starting to have an understanding of what irresponsible activities in space can be, such as, creating long-lived debris in outer space, and we're starting to work through some of those norms in both a civil and a national security context. But a lot of this is really at the foundational. That's one of the things I find very exciting about this issue, is that we haven't done a lot of intellectual heavy lifting on this issue yet. Through hundreds of years of practice, we have come up with norms of behavior on land and at sea. We are just at the beginning of thinking about these issues now for outer space and how we would apply them. And it's going to take a long time to figure out, working both with the commercial side, with the civil side, and as well as the national security side, what are these rules of behavior? What would we consider to be hostile activities in outer space? And we need to figure those out and come to a consensus both here among groups like this and then internationally, so that we can start creating these standards around the world.
This question is for John. You had your lovely slide on space mission taxonomy. There's a question about that. In it, you discuss protecting via defensive counterspace. The question wants to know, in terms of offensive counterspace, where does attacking a co-orbital ASAT fit into your taxonomy for mission assurance?
So that's a question that really gets to basic doctrine. What is the difference between defensive counterspace and offensive counterspace? What I had in the slide is defensive operations, resilience, and reconstitution. And defensive operations are, like the destroyers that are surrounding the carrier and protecting the carrier, or there are onboard systems on the aircraft carrier that defend itself. When those capabilities eliminate the threatening system, that's a defensive operation. I'm defending myself by defeating the threat. And the question about offensive counterspace, as a purely doctrinal term, offensive counterspace would be referring to taking away someone else's ability to use space for themselves. So defensive counterspace is defeating the threat that is coming at me. Offensive counterspace is taking away someone else's ability to use space. That's how we define those terms and use those terms.
Another question that came in, does having the U.S. military being the single node for SSA for the world increase resilience?
Well, as compared with having 0 nodes for those activities, yes, it increases resilience. Is it optimal? I would generally argue that having the United States provide global situational awareness, space situational awareness for the world as an externality of our core mission is probably not in the world's best interest, but we're pleased to do it right now because it is important. It is important to us in our self-interest, but I think it is also important to all the space operators, U.S., international, civil, military, commercial, to come up with something that is more comprehensive and involves all the operators in the problem. Ultimately, I think as space activity becomes ever more dominated by non-military operators. Military will still be a big part of it, but as non-military operators take up a bigger role in space, just as we saw in aerospace many decades ago, you really want to move from a military foundation of your space traffic management to a civil foundation and an establishment of the norms through the entire community of operators. It may very well be that such a system has to rely on much of the data that the military collects. The military will still have telescopes and radars and so on to collect and analyze data, and it's probably very important to continue to provide and support the system because, frankly, from the military's perspective, it's in our interest that people have that data and be able to use it as well to ultimately have space be sustainable. I think in the long run, we're better off finding a structure that is not asking the Department of Defense to spend a lot of its time and energy focusing on something that is not really a core mission of the Defense Department. And then have an entity, and whether it's individual countries or whether there's some kind of international consortium, I don't know, but to come up with more civil-focused entities that provide the broad service that becomes more of a global space traffic management approach.
Angie, would you say that the military is the only node for SSA?
Of course not. But I think to John's point, I mean, there are multiple nodes. SDA is a node, but SDA does not, other than its satellite owner-operator members, have sensors, right? Its sensors are the ranging and other orbit determination activities of its members, plus the information that comes from, thanks to the U.S. taxpayers and the U.S. Department of Defense, on debris and other cataloged objects. Right? That's what enables it. I think what we are seeing, though, and some of those firms are here, is we're starting to see the emergence of, if you will, non-government sensors that can do things like build catalogs of space objects and debris. And we're seeing the emergence of information processing systems that take advantage of advances in computational theory and Moore's law, to derive some very basic catalog creation activities that, until recently, were the sole domain of nation states. That trend will probably continue, and some of those services and systems will evolve to perform, I believe, some space traffic management functions. But it's not going to take away from the need for governments, particularly the United States government, to maintain its own series of sensors to carry out nation-state specific missions, such as missile warning. Right? I don't think there are some things in this world of SSA that are essential government functions. So I don't. Is it inefficient to have multiple nodes? No, it's not at all inefficient. I can tell you that the collaboration, for example, between SDA and its technology partner AGI and the JSPOC, I've watched it evolve over years from just at the human level, from you guys are just duplicating our mission, not adding value, to, oh, we can actually help each other spot discrepancies in things like leap second implementation, or when objects are lost, which happens with the SSN due to technical limitations of, for example, of telescopes acquiring objects. We can find them, we can say, well, here's our information, let's give it to you. Let's make it easier for you to recover that object. So I think that's the trend it's just one example, but I think that's the trend we're seeing, and I think we're gonna go in that direction to a multi-node. But at some point, I believe there's some work for example, from DARPA on this with their Orbit Outlook program. You do have to make sense of all the inputs, of all the data coming in, and you have to somehow determine what is valuable and what is perhaps erroneous. And that is a really hard problem that many of you are working in the audience. We don't have the answer yet on that, but I think it's going in that direction.
Next question is for Eric. Could you envision a day that SSA sources and methods from private or commercial entities are used as a tool for engaging your foreign counterparts, similar to commercial imagery and remote sensing?
Absolutely. I think, even today, we have seen such an amazing transition, especially with the commercial imagery. I saw just the other day there was some commercial imagery being used on CNN.com, and so I can see definitely a future where being able to go to commercial sources for the information will be invaluable for our efforts to go and talk to other countries about their behavior in outer space. I think right now, I think the data, for example, for conjunction summary notifications that the JSPOC sends out is currently an essential element of our international engagement on a lot of these issues. It is certainly a great example of where the United States is leading other countries in terms of providing a good that helps other countries avoid creating additional debris in space by making sure that your satellite doesn't smash into somebody else's. And so to the point in the future where we can be sharing this through other means, I think that is a great future to be looking forward to.
Building off the earlier question about diversification, someone asked, another method of doing so is sharing the SSA mission, especially catalog maintenance, with our allies and partners. Is State Department and/or OSD policy pushing for more multinational programs to increase collaborative SSA systems development with other responsible nations?
Are we limiting ourselves to just responsible nations? I mean, yes, we are trying. We want to. This is a team sport, okay. The United States has been doing space since the late 50s, early 60s, And so we may be the biggest kid on the block, but everybody who is involved with space in one way or another has interest, has something they can contribute. And it's technology, it's on-orbit systems, it's land-based systems, it's many different phenomenologies. And our space situational sharing agreements that we have, for example, we're very much interested in making them more of a two-way flow. And we're not, I mean, don't be shy. Don't say, well, gee, I don't have that much to give you. You know, we're very much interested in what people have to make the catalog better. And then, as we talked here as well, and Andrew discussed, we're learning how to play better with other people who are in the game too, and share the information we have, and try to be collaborative in improving the overall ability to understand what is happening in space faster, better, more precisely. Thanks.
Let me just echo what John was talking about. You know, the space situational sharing agreements are an essential part of our efforts to encourage other countries to cooperate. Just having come from Australia, as I mentioned, it is amazing to me the amount of money that they are putting into their own capabilities, the amount of money they're adding to our money to put the Space Surveillance Telescope there or to get the C-band radar up and running. In fact, the C-band radar is going to be run by all Australians, and so there won't be a single American at that site. So to the extent that we can get our allies and partners working together on these issues is really helpful for expanding that capability. What we do in the State Department often is we have what is known as a space security dialogue, and we have that with some, I think, 15 or so countries around the world. And oftentimes we spend our discussions, you know, usually it's an interagency discussion where we talk about what space situational awareness capabilities countries have, where they're going in the future, and what ways they could tie into our systems in the future. So for example, we were just meeting with the Japanese and they provided us an analysis of what their thinking is on space situational awareness capabilities, which then we can start working with our colleagues in the Defense Department to help see how their systems can help work with our systems.
Victoria, I have a question, but do I have to text it?
I think we'll let it go this one time.
Okay. The question about sort of, I'm going to use the word outsourcing. That's not the word people use, but it was moving the DoD's role in supporting the space traffic management out of DoD to other places. I wanted to ask Eric. Obviously, we're not going to outsource diplomacy. That's the core mission of the State Department. But how does the State Department's diplomacy related to establishing norms in multilateral fora and context or bilateral, what's the role for the civil and commercial sector in working with you in collaboration in those activities? That actually was a serious question, believe it or not.
Well, thank you for that question, John. I appreciate that. So we do engage with industry a lot. Do we engage with industry enough? I'm not entirely certain that we do, but I think in contexts such as COPUOS, we do try to engage with industry as we develop these guidelines. I think there is a role for industry to play as well in terms of determining and helping us figure out what norms would be useful. And then also, as they talk to your foreign counterparts, your foreign commercial counterparts, your foreign civil counterparts, helping us to echo the message about good behavior or irresponsible behavior and helping to reinforce the norms that we are trying to develop around the world. I think as we move forward, as I talked about in developing these future norms, there is a huge role for the civil industry to play. Whatever we as the U.S. government decide to do, we need to make sure that it is consistent with your practices, that we're not going to cause you undue burdens on your capability to operate in outer space. So there is a lot of work. I think there's a lot of partnership that needs to be done. I think the partnership is it comes without dollars on our end. Perhaps, my DoD colleague would be better to approach if there's issues related to that.
Policy has words. We don't have any money.
Your organization has a lot more money.
Andrew, do you want to add to that?
I would just point out that it's just anecdotal. My experience with the State Department is that they're in a difficult position in forums like these. They talk a lot about international engagement, what they do, right? But all of us in this room know that diplomacy is carried out in many ways at many levels. And sometimes things that aren't discussed in public are very effective. And industry engages with the State Department, again, on many levels. And there are many successes that unfortunately go unheralded in forums like these. So could there be more? Yes. Could the State Department be more responsive to industry's needs of the moment? Of course. Would I want to be engaging with other nations? I have. We're very, very fortunate here in the United States that we have the institutions and the people in them as they are. They do a really fine job in a very tough environment.
Just to add, there's, as we heard from Sandy, there's 60 foreign participants here. So, I mean, this shows that this type of environment is a great opportunity to discuss those issues because it is an international conference. There are chances to engage with your foreign counterparts right here and right now.
Could the panel discuss, from your own perspectives, what are your short-term priorities for SSA?
My short-term priorities for SSA are whatever John's short-term priorities for SSA are. Thank you.
Is Colonel Giles here? He's the JSPOC director. What are your short-term priorities for SSA? It's more data, it's better calculations, more sensors, and that's just like it's more cowbell. It's not just more cowbell, but then really that's on our production side, as it were. But it really does come down to more international focus on what is potentially going to happen in space with more and more small sats going up there, more and more activity in space, and how much, what is going to be the slope of the curve of the risk of conjunctions in space. And the damage that can do to the individual operator or to the environment in space. That awareness of it is absolutely as important, and then figuring out how to do something about it is just as important as more cowbell in the acquisition of data and calculation of it.
I'll bring an industry perspective. Those sound like midterm goals to me. In the really short term, I think we have to focus on the physical connectivity for the exchange of data that leads to the exchange and understanding of information. We can do that amongst the parties operating space. We can continue to do more with JSPOC. In fact, industry is. I think we heard about the commercial integration activities taking place there in Colonel Giles' shop. It's really encouraging. We just literally have to get those systems talking to each other and evolve our thinking to try to get the humans out of the loop and try to get that information so that we're shared in a way that we're subject to the constraints we have. We are all looking at that same information and it becomes decisional quality. And we are trying to do that.
Well, the last question, I think, since we're running near the end of our time, is looking at long-term view. Taking a step back from current policy debates on transparent confidence-building measures and mission assurance, what is your long-view conclusion of the ultimate disposition of the national security space domain?
do we look at long-term in terms of the age of the universe or in the age of the nation state? For us in the defense world, I think it's near term actually, but it's a continuous transition to deal with. For us, it's dealing with the contested aspect of space, and recognizing that we began our operations in space from the perspective that was mostly uncontested. And as has happened in every other domain of human activity, over time, things become contested. And ultimately, what we're trying to do is deter conflict. So for DoD's perspective, you deter conflict, and this has been pretty much a foundational thinking of security strategy for across societies, across millennia. You deter conflict by being prepared to deny an adversary the benefits of a military option. So for us, it's what do we need in space situational awareness? What do we need in the resiliency of our systems? How do we change the way we operate to such that the things that may have been seen as attractive targets in the past are recognized as actually not being very good targets at all, and that extending conflict on Earth into space is just not a productive option. That's what we're focused on, and the SSA is a big part of that.
I'll just build on what John said. I think in the long term, we need to get past, I'd like to get past where we are now, where conflict or hostile actions or hostile signals are taking place, and a very small community, those of us here are aware of that, thinking about that, to a model where hostility and conflict in space are seen as antithetical to our global society because they interfere in our ability to exploit space and preserve our way of life, right? It's right now, there was outrage at the, I think well-deserved, at the Chinese ASAT test some years ago, but not enough, right? There's not enough, and even today there are space operators that think about exploiting space without due regard, in my opinion, for the long-term consequences of their actions, whether it's building systems that leave debris in orbit for long periods when the systems become inoperative, or the way they operate. So I think I'd like to see, the person on the street understand that space it's a very important domain, not only for their security, but just for their way of life, and we create sort of a global moray that says, space needs to be preserved, just like we generally don't dump bad chemicals into places because it fouls where we live. We need to establish that. It's going to take some time, and I'm afraid we're going to have to, since we're reactive as humans, I suspect we're going to have some more incidents before that emerges.
I would say for me, the long-term goal is to put myself out of a job because there are no challenges or issues related to the outer space environment. But I think, to be realistic, it takes a long time for these norms to develop. When we think about the norm that eventually led to the International Committee on the Red Cross, or the idea that, don't attack medical corpsmen during a conflict, those took a long time to develop, to become a norm. Chemical Weapons Convention is another great example where we've got pretty much the entire world to agree that the use and development of chemical weapons is immoral. But there are still a few outliers out there that have not joined the treaty and who still think that it's in their national security interest to have that. So I think the long-term goal is to meet the national space strategy's goal of peaceful uses of outer space for all countries, with norms that allow us to understand what responsible behavior in outer space is and to avoid activities that would cause the misperceptions or miscalculations that could lead to conflict or the destruction of a satellite in orbit that is just up there doing commercial activities.
Well, we're just about at our coffee break, so I'd like to thank the audience for sending in such interesting questions. And please join me in thanking our panelists for providing such interesting responses.